Hello and welcome to Physical Geology. I am Robert Lopez, and this is a 4-unit course that involves lectures. So you'll be taking notes on these video lectures that I do, and you'll see that each lecture topic has a series of study questions that the answers to those questions will be right here from these video lectures, and then I use those study questions to help me write the exams. The other part of the course is use of a Geology Lab Kit. So obviously you'll purchase this lab kit and you'll be able to do the labs at home. And I'll go through that here in a moment. We'll be using the Kmz Learning Management System. To access it, you'll go through the West Valley College website and you'll see that there's a Canvas link up here at the top page. And this login page requires you to put your student ID number, then your password. And if you don't have a password yet, and you're new to the college, you would use your birthday in this format here, right? Once you're into Canvas, you'll come to the dashboard, and our class is Geo1A 7595 section here. Once you click on our course page, it would take you to the home page here, and you can see there's some information about the textbook and the Geology Lab Kit. Another important item on this page is a to-do list over here on the right. So we have several assignments coming up that are due September 2nd, and you can see this will be the list. The next thing I want to talk about here is the syllabus. So I have posted the syllabus here on our course page. And this is the same thing I emailed you earlier this week, but the information is here. Contact information, office hours, requirements for the course. You want to make sure you read through this. As we go down to the bottom, another thing that this will offer us is the course summary. And again, here you can see what assignments are due each week. So I pretty much have the whole course ready to go. And you can see that for this first week, we have several quizzes and assignments you're going to be doing. And you can kind of go through it week by week, all the way through December 16th. Now, the next part that's really important here in the Canvas page is where all the course material is going to be presented. And that's in this Modules tab here. So in the Modules tab, it'll take you here, and this is where you will see the week-to-week assignments that we'll be doing for this class. Each module will have a learning guide, and it's basically the list of what you need to do for this particular week. So for at least for this module, we're going to do the course introduction. I'm going to talk about Canvas, which I'm doing now. I'll talk about the smart work and Google Earth here in a little bit. You'll take the syllabus quiz and some quiz based on this video as well. You'll learn how to download Google Earth if you haven't done so already. And the GeoTours Kmz files you'll need for some of the lab assignments that we'll be doing. And then you'll take the practice quiz through smart work here. Let's look here at Chapter 2, which is Plate Tectonics. And if we click on this learning guide, these will be all the topics I want you to do for this particular module for Chapter 2. Again, if you haven't received your textbook yet, I've provided Chapter 2 as a PDF file here so you won't fall behind. So you can see that I want you to do the smart work assignments. I also want you to obviously watch my online lectures. You'll see that my online lectures, there's a series of study questions that go along with my lectures, and so you want to take notes on my lectures, and then you'll answer these study questions as best you can. And then what I do for exams, I use some of these questions for these exams. So it's really your study guide for the exams. And then you can see that I have these Tectonic geode animations I want you to go through. They're little animation tutorials you watch. They're sort of interactive, and then at the end I want you to take a geode tectonics quiz based on that animation. For this particular module, we're going to do a discussion on how Africa and Europe are really in a convergent zone tectonics, where there's subduction. We have the volcanoes there in Italy on Mount Etna there in Sicily. So but it may be changing. And so and we've had some recent earthquakes there in the past year and a half in Italy, where it indicates that there might be a shift in the tectonic activity that's going on there. And then there's the Google Earth lab that I want you to do on tectonics. And then there's a visual quiz. Then there's the Building the Planet Lab from the Geology Lab Kit. And then there's another article on Iceland and the Mid-Atlantic Ridge that I want you to read. And there's some 3 or 4 questions on it, and then plus a short answer essay question on it. Right, so that's the topics you want to go through for each of these modules. Now let's go back and we'll look at Google Earth. I want you to look down here, and there's Google Earth and the Kmz files. So for this one, what I want you to do is download Google Earth onto your computer. So you can do it here. And also you need these GeoTour files. But before you download the GeoTour's Kmz files, you want to download Google Earth. And so when you click on this link, it'll take you to Google Earth, their webpage. Google Earth now is using Chrome, so they want you to use Google Earth Chrome. The Kmz files that we're using doesn't really work with this Chrome. It doesn't allow us to measure things like we normally do with the older version. So you want to come up here to the top and download an older version of Google Earth here. And once you click here, you can download Google Earth Pro. And that's what I did for my computer there. And so you'll be able to open that up, and then you can download the Kmz files. So I'm not going to do it here. I'll let you do that on your own computer. Now for the Kmz files, when you click on the Kmz file, make sure you download this one here. There's another version of Essentials of Geology GeoTours, which is the first version. You don't want to use that one. You want to use the second version. So download this one here. Click on this one, and then it's going to ask you to open it. And so once you download Google Earth on your computer, you're going to choose to open this with Google Earth. You'll open it, and it'll open. I've already downloaded it on mine, so I'm not going to do it now. But that's how we're going to get to the Kmz files. In a later video, I will show you how to use Google Earth when we do this Earth and Sky. So when you click on the Earth and Sky assignment, I will have a video posted showing you the instructions for Google Earth. What I want to do now is actually look at the eScience labs and your Geology Lab Kit. So you'll see that the eScience labs are now linked through Canvas. So what you'll want to do, you'll click on this assignment. So this is our first lab out of the lab kit. It's called Building a Planet, Lab 1. You'll click on this, and it'll take you to a web page within Canvas. So here's the 2 web pages. So we'll do the pre-lab first. So we'll click on this here. And in this lab, you'll see the learning objectives. You're going to want to read through the material here. There's a series of topics. In fact, you could kind of scroll through this. There's even audio here. At any rate, there are several little topics here. You want to go through these that kind of are background material to what we're going to be doing. And then as you go along there, you'll read the introduction, hear about the Big Bang and Singularity. I think the question they want down here, this little fact check, began from a single point, right? And then experience this incredible expansion. We'll talk about primary heating, the layers of Earth, and the planetary differentiation. I usually call that gravitational differentiation, where the heavier material sinks to the core, a lot of material forms a crust. But this kind of goes all through here. One of the things that I like about this little introduction here is that they do kind of look at the Earth in chemical layers versus physical layers. And in my lectures later on, you'll see that I pretty much talk a lot about these chemical layers. There's the core, the mantle, and the crust. But also, I talk about these, and I don't emphasize that they're chemical or physical, but just know for now, just to get us started off on the right foot here, is that the chemical layers, the core is primarily iron and nickel metal, high density. The mantle is mostly a silicate, magnesium, and iron. And then when we get to the crust, we got sodium, calcium, silicon up here. So there's a chemical variation, again, based on that gravitational differentiation, that planetary differentiation. Remember, a differentiation refers to a separation, right? Now, for the physical layers, there's inner core, outer core, and really the mantle is really broken up into this mesosphere, asthenosphere, and the lower parts of the lithosphere, right? So one thing about this lithosphere, and lithosphere are the tectonic plates. So when we think about the lithosphere, we're really talking about tectonic plates. The thing about the lithosphere is kind of a hybrid layer. It includes parts of the uppermost reaches of the mantle, plus the crust, right? So think of this lithos, it's a Greek word for rock or stone. So it's a rigid or rocky sphere of Earth. Whereas a stenosphere here, a steno means weak in Greek. It's a Greek word for debilitated or weak. So the asthenosphere is kind of like silly putty. It flows. It's sort of like a solid or like a liquid. It's kind of a strange material, but it allows the tectonic plates to move and slip and slide above this weak asthenosphere. So at any rate, you're going to go through this material here. Here it goes, chemical layers, physical layers. The important thing at the bottom here is you'll kind of go through a little quiz. There's a little Quizlet you go through here based on some of the readings, right? So here, the temperature of, that's false, right? The temperature of Earth's layers decreases a function. No, actually they increase, right? So, and then you'll wait and it tells you it's correct answer. You click anywhere and it takes you to the next question. And here, most minerals in the crust contain primarily what elements? Sodium and calcium are the ones they discussed in the topic up here, and correct. So you kind of go through all those, and then you want to do the pre-lab. So when you click on here, it'll give you a link to Microsoft Word. You'll download these questions, and the important thing about these questions is once you complete this assignment, this is what you need to photograph, or you need to scan or make a PDF of this or something, and this is what you want to send me in the Dropbox, right? So if we go back to our lab over here, you'll see that in here there's a submit assignment button. You'll click on here and you'll attach those files on here. So there's a pre-lab and there's exercise 1. Let's look at exercise 1 real quick. So for this exercise, there's some rocks that come with your Geology Lab Kit. You'll use those rocks. You're going to determine their density, right? You'll determine the density based on this equation here. And then you can look at there's a scale that comes with your kit, and you want to calibrate it. So you watch that little video tutorial on there. There's also, there's how do you read a meniscus in a graduated cylinder? So there's a little tutorial on that as well. But again, at the bottom here, you'll want to follow these instructions, but then at the bottom here, you're going to download the data sheets. And so again, these are the ones that you're going to submit. So here you'll have the rock samples. So there's unknown rock 1, unknown rock 2. You're going to weigh them on your little balance. You're going to determine their volume. You're going to determine, or the volume displaced here. And then you'll figure out the volume of the rock here. And then over here, you'll determine the density. Remember, the density is the mass over the volume. And then based on the numbers you get, remember, you're doing it 3 times to get an average of the sample here. And then you'll compare it to these densities to see what your material, what your rock most closely represents here. And then there's more information. You'll answer some questions here on the data sheet. One of the things about this question number 8 here, they give you the mass, they give you basically the volume of the block here. It's a wood block, and they give you the mass. So you can just determine the volume, and here's the mass. So it's a mass over the volume will give you the density, right? So that's how you figure out this density. But then over here, they give you, use that same density you calculated for the block. You know the density of water is 1.0 grams per centimeter cube. But this equation, I don't like the way they have it formatted here. So it's really the density of the block, which you calculated in the preceding problem, divided by the density of water, which is 1, right? 1 gram per centimeter cube. And then equals this R, which is the height, or the height of water of the block underwater. And then here we're going to put divided by right here, divided by H, and H is the total height of the block. The tricky part here, and I had a problem with this until I realized, they give you H. H is right here. H is the height, so H is 8 centimeters. So you want to use 8 centimeters here. You know the density of the block because you just calculated it up here. You know the density of water, which is 1.0. So all you're doing is solving for R, and that's what they want you to do, which is they want you to know the height below the water.